and add.
Pudding. And let's look at what we will be doing today. Okay. All right, let's see. Share my screen. Okay, share my screen. Okay. I don't believe I don't see what I want to see here. I don't know. You probably don't see this GED topic shares.
No, what's on the screen is just still
Yeah, I
music.
know. Well, let me see here. Share screen. Oh, that's the wrong thing. Wait, new
Yeah.
share. No, that's the wrong thing. That's the. I'm trying something
The binomial.
new.
No.
Yeah,
Okay.
that's for this afternoon, for later.
Oh yeah, that's just for yeah.
Right. I want to try. I tried to put everything up because I wanted to see if I could get around that problem I was having before. Okay, let's see. Now, do you see GED math topic schedule?
No, not as yet. The same
New
5th of the
share.
9th.
Okay, let me go here. Okay. Now you should see it.
Yes.
GED math topic schedule. Okay. And what we will be doing is going over the homework that was on fraction, decimals, percent. And then hopefully we'll get into applied math. And that's something, Mercedes, I think you, well, I know you know about it. You know how to calculate mean, median, mode, right? Range.
Yeah, I hope I don't forget.
I think a lot of them will be reviewed because we've done it before, but that's okay. We'll do some practice problems. But first, let's look at the homework. Okay, new share. And I want to go to the homework. Okay, see me, math GED prep homework?
Yes.
Okay. All right, I'll say these now. Let me just look at, I recorded what you sent me. You sent me all your homework. And you had the first one right, but we'll go over it anyway. And you missed the second one. And as I said, I don't know if you got the email I sent you. You missed number 2, 7, 8, and 9. But we'll go over all of them. All right. Because you're the only one who sent the homework.
Oh boy.
Okay. And well, I won't say that, but I know you're quite busy and with long hours you're working, but yet you still sent the homework. Okay, let's look at number 1. Now, number 1, when you look at this diagram, Mercedes, what comes to mind when you look at this diagram?
You telling me that I have 3 whole.
Right? And what else?
And 3 and 1, 2, 3, 4, 8. 3 upon 8.
Okay, very good. So you recognize that there were 3 whole circles shaded, right? And then you had the 4th circle that had, like you said, 3 out of 8. And the reason you said 3 out of 8, because when you count up all the slices here within the circle, you have 8. So 8 over 8 is the whole. So you recognize that this was a mixed fraction, right?
Yes.
Because anytime you have whole and fractions, we call that a mixed fraction. That's why they ask you, right? What mixed number is represented by the shaded portion? And so you said 3 wholes, and you said 3 out of 8. And that would be which answer here? A, B, C, or D?
The answer would be C.
Answer C. That's right, because answer C says 3 and 3/8.
Yeah.
Very good. Very good, Mercedes. Now, you're going to kick yourself on number 2.
Oh my.
I guarantee you're going to kick yourself how you missed number 2. In fact, I'll have us go through it, and you'll tell me the answer for number 2. And if you do tell me the answer after we look at it right now, then I'll correct your answer, and that way you'll have another one correct. Okay, is that fair?
Oh, yes, fair enough.
Okay, now look at this figure. What fraction of the figure below is red? Now, so what's the hole in this diagram? I'll say this. What's the hole?
The one in this diagram is oh no.
How many blocks in the
We
whole
have
diagram?
16, 17, 20, 20.
20, right. So the hole is 20. 20 over 20. That's the hole. Now, how many do you see shaded in red? How many blocks?
14.
14. Very good. So we write that as 14 over 20. Right? Now, let's go back to say what, and I want you to read to me what they ask you to find. Read number 2.
In the lowest terms, what fraction of the figure below is red?
So you said what?
Oh, the answer I gave you was what again?
You gave me B. You said the whole is 20 and 14 are red. 14 over 20. But
would it have to for fraction?
yeah, but no, read again what it asked you. 14 over 20 is a fraction, but read the whole thing again.
In the lowest terms, what fraction, in the lowest terms, what fraction of the figure below is red?
Now you said 14 over 20. Is that the lowest terms?
Oh no.
What is the lowest terms
The lowest
of 14 over 20? What is 14 over 20 equal to?
14 over 20.
Yeah, when you reduce it, what do you get?
I will get oh my god. C, 10 over 7 over 10.
That's it, Mercedes. So
You
just earned yourself another point. 7 over 10. You see why I said you're gonna kick yourself when we go.
Oh Lord, Miss Barbara, because I really go to C and I go back to B and I come back to C. Oh shit, but it's 40 and I just say B. Oh Lord.
That's why I had to read it again, Mercedes. In the lowest terms. Right?
Oh, so I should have calculated that out.
You should have simplified it or reduced it, or it means the same thing because it's not in its lowest terms. It is 14 over 20 because there are factors in 14 and 20 that allows you to reduce it, right?
Yeah, can use 2.
Yep, you use 2. You're absolutely right. 2 into 14 is 7 and 2 into 20 is 10. So your answer
should be
C. Okay. So let me make a note of it, Mercedes. You remember I said when you go over it, you're gonna get it right. I knew you would. Okay. So I recorded that. Let me put now you said C, so that's correct. So now your score went up by 10.
Thank you.
Very good. You see why it's important to read these problems, Mercedes?
Very, very careful.
That's right. That's why I had to read it twice. In lowest terms. If I didn't say in lowest terms, then you would have been correct, 14 over 20. I say, what fraction of the figure below is red? 14
Yeah,
over 20 would be correct.
It's like you're saying,
Mhm.
simplify, but you don't have to tell me simplify it the lowest term.
Lowest terms mean simplify. Now,
I
if
don't-
I had said what fraction of the figure below is in red, I would have given you C, because I wouldn't give you a conflict. I would give you the 14 over 20, and then I'd give you something else for C, because I don't want two answers to be the same. 14 over 20 is equal to 7 over 10.
Okay.
Got it? Very good, Mercedes. I knew you had it right. When I saw that, I said, Mercedes got that problem. And you did. When you looked it over, you said, oh my goodness, 14 over 20 is not the lowest terms. You saw that right away, right?
Yeah.
Very good, Mercedes. Now, number three, you said, I think number three you had correct. Number three, let's see. Number three, I think you had correct. Let me look at. Okay, number three you had correct. Now, Mercedes, tell me how you did number three. You had it correct. A couple of ways you could do it. Tell me how you did it. Read it, then tell me how you did it. Number three.
Okay, number three. I read 3 inches on a map represent 100 miles of real distance. The distance between Adams and Moray on the map is 7.5 inches. How many miles separate the two cities in reality?
Okay, so it's like a scale here where,
Yeah,
okay, where,
I almost didn't do it, and then I left it. Come back and read it again,
okay,
and I think I say, forget about the two distance between the city. I'm talking to myself. I said, don't make that frighten you. Look
Oh.
at it. Look at it. I says, okay, 7.5 inches. So I said, if you divide, because 3 inches on the map represent 1 mile.
100.
100, 100 miles.
Okay.
And then so I says inches. And then I said, okay. I said a map is 7.5 inches. I said, did you do the inches? So I said, okay, let's divide up the 7 and see what I got.
Okay. So 7.5 inches divided by 3 is equal to what? Is that what you did? 7.5.
Inches divided, yeah, and I got.
Okay. Divided by
3.
3. Let's see, 7.5. Let's put that here.
Think about it, I just show my people that I do the work on.
And then you divide that by 3. And what did you get, Mercedes?
What did I do again? I know I sit down and did it right. Can you scroll down and look at me, read it again, please?
7.5 divided by 3. What did you get when you divide 7.5 by 3?
7.5. I got 2.5.
Okay, very good. So you got 2 and
You know, I did it
1.
mentally, Miss Barbara, first. I didn't use I didn't use my calculator first.
That's right. This is a
I
good
started
mental
with
math
mental.
problem.
I said, but this is 2.5.
That's right, 2.5. So 7.5 is 2.5 times what the 3 inches represent. So then what did you do with that 2.5?
What I do with 2.5? I take the 2.5.
Okay, you took the 2 and 1/2. Very good. And you
I
did
think
what with it?
I'm trying to remember if I divide it into the 100.
No, you would have had to multiply it, right?
Yeah, I did.
3
I know.
inches is 100. Seven and a
Yeah.
half is going to be greater than 100. So you multiply that 2.5 by 100, right?
Yes. Yeah. Do something like that.
Yes. And if you
Because I doubt
multiply
the
that,
paperwork. Yeah.
and what do you get when you multiply 2.5 by 100? That's a math.
I got 0.025.
No, 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 no.
Wait.
2.5, not point two, not 0.25. This is a whole number 2.5. So remember, that's the same as saying 2
Oh yes.
times 100. Let's
Yeah. I
just
got I
break it up.
multiplied by, and I got 250.
That's it, 250. Because that's the same as saying 1/2 times 100. So let's just put this in parentheses. That's the same as multiplying the whole number by 100 and then the fraction by 100, right?
Yes.
So that gives you 2 times 100 is 200, and 1/2 times 100 is 50, and that's how you got the 250. You can do this all by mental math. 200 plus 50.
Yes.
That's equal to 50. Okay. Yeah, this is a
I,
mental
I,
math problem.
sorry, and I stopped and started to move the decimal point. As if I move the decimal, mentally I'm doing that. So I move the
Yes.
decimal point to the right. How much time I'll get that? And I said, oh, I'll get 250. So
Yeah.
because I doubt myself, I go in the calculator now, and I did it. And I
And
see I was correct.
and you could have made this a decimal. 2.5 is what is a decimal, Mercedes? To what?
Um, two in a decimal.
2.5 as a decimal is equal to what?
2.5 as a decimal is equal to what again?
It's
To
2 and what?
2.5.
That's
2.5.
it, 2.5. Very good. And then 2.5 times 100 is 250, right?
Yes.
So you could have made it a decimal and multiply that by 100, and 2 times 100 is 200. 5/10 of 150, and you would have gotten the 250.
Yeah, because when I see the 250, the 2.5, I say, oh, if I move the decimal point, I'll get 250. Must be the easy answer.
That's it. Very good. Very good. Now, there's another way you could have done it. You could have done ratio, proportion, right? You could say
Mhm.
3 over 100 is equal to 7.5 over an unknown, and then cross multiply. So you could
Okay.
also use ratio and proportion. So you can do it this way, or let's put here ratio proportion can be used. So you could set it up ratio proportion, all right? Because you know how many 3 inches represent 100 miles, 7.5 inches represent unknown number of miles. You could solve it that way. That's another way. But this is really mental math, right?
Yes, because honestly, I look at it first and I leave it, and I go do the rest and come back there and say, like I said, don't leave it, try it again. And I go back. I says, oh, the inch is 7, and the
Okay.
and
Very
it's 3
good.
inches. I started to think by myself.
Right,
I said,
right.
yeah.
So you knew your answer. Well, all your answers are greater than 100, right? But if you kind of reason it out, you say 3 inches, 7.5 is really more than
Too much. Yeah.
twice 3. So I know it's got to be more than 200, right?
Yes. Yeah.
Yes, you can kind of reason it out, right?
Yeah. How did you set up the ratio one? 3 of 100.
Yeah, 3 over
And what?
100. Yep. 7.5 over n, and then cross multiply and solve it. That's another way. But this is really a good mental math problem,
Yes.
because you can eliminate like 300 means it would have to be how many inches would give you 300? I'll say these.
It would be 3 times What did I get for it again?
3
'Cause I
inches is 100 miles.
yes.
But if you had 300 miles, how many inches would you have on the map that represents 300 miles?
I would have to up 3 inches is 100 miles.
So if you want to represent 300 miles, how many inches would you have?
I would have to have 9.
That's right. You'd have to have 9, but this says 7.5, so you know it's got to be less than 300,
Yeah.
right? So that's another way of figuring it out too, right?
Yeah, yes.
Said,
Yes.
okay, if I go up to 300 miles, that's 9 inches, but they're telling me the distance is 7.5 inches between
Yeah.
these two towns. So I said, well, then it's got to be less than the 300. Yep. Only two numbers less than 300 is 150 and 250. 150 is not big enough. All right.
Okay.
So you can kind of reason out why sometimes your answers, you can eliminate some of your choices so that you don't have to look through everything. Okay. All right. Now you got that was what, number 3. You got number 4, right? Okay. Betty scored 36 out of 45 for her math test. What fraction did she get wrong? Okay, now Mercedes, you had this one correct. Tell me how you did it.
Well, did I do it again? First, I subtract 36 from 45.
Okay, so you said, well, if she got 36 right, 45 minus 36, and that's equal to what?
9.
That's equal to 9. That's the number Betty got wrong. Okay, we just used the same kind of wording they used here. Okay, so
you see right here, Miss Barbara?
yes.
When I did the first part here, I went blank. I said, oh my God, what did I do again? What did I gonna go say? What fraction? So, oh, what fraction?
Numerator over denominator. So then what did you do? You got 9, she got wrong. How did you get the fraction?
What did I do again now? I think I turn the 9 into decimal.
No, you didn't do that.
I'm trying to remember what
Remember,
I did.
fraction is part over whole. So what's the part here?
The 40 45.
What's the part? The number she got wrong, right?
Yes, it's 9.
And
yes,
that's 9. And what's the whole? Total number of questions.
45.
That's right, 45. That's your part over your whole, right? So 9 wrong.
Oh yeah.
Total questions 45, because it's 36 out of 45. That meant there were 45 as the total points, right? Or total questions. Okay, so 9 over 45 simplified. What is that equal to, Mercedes?
That is equal to, hold up.
Mental math.
Okay, 9, 5.
Now remember, this is 9 numerator, 45 denominator.
Yes. So, 9 5 is 45. So 9 to 45 is 5. 9 to 45 is 5.
No, this is 9 over 45, not 45 over 9. In other words, this is 9 to 40. It's like this. 9 is the numerator, right? And 45 is the denominator. So this is 9 over 45, not 45 over 9. What is that equal to, Mercedes?
Okay, we have to say 3 into 9 goes 3, divide by 3.
Yeah, but 9 and 45. What are the factors of 9?
3, 1, 9,
Okay, what are the factors of 45?
15, 3,
What else?
9 is one factor.
Right. So 9 is a common factor for both 9 and 45.
Yes, yes.
All
So
right. So that's
9 into 40.
the highest common factor will give you the simplified, the most simplified of the fraction.
Okay,
So you
okay.
would do what? What would you do with the 9 and 45? Divide the numerator
Divide
by what?
by 9.
That's
9.
right. That's right. So you divide this, let's just put that there, by 9. Then you divide the 45 by 9. And what does that give you, Mercedes? What do you get here?
Give me 1/5.
That's it, 1/5.
Yeah.
That's it. And that you had that one correct. That's answer A. Right? Now, I'm glad to see you subtracted to get the number wrong. I mean, that's the straightforward way to do it. I mean, you could have gotten the number right and subtracted it from the whole 5/5, got the same answer. But I think the way you did it was a little more straightforward. How many she got right, subtracted from the total, give you the
And
number
then
she
use
got
the 9
wrong. That's right. Then use that 9 over
to get the
45 to get the simplified
fraction. Yeah. I say, what fraction did she get wrong?
Right, because they didn't give you 9 over 45 as a choice, right?
Oh, no.
So that tells you that all of these answers are in simplified form. Okay.
Yes.
Okay. Very good, Mercedes. You really getting this. I'm really
Thank
proud of
you.
you. Okay. Let's look at number 5. And number 5, you had correct. And tell me how you did it, Mercedes.
Can I scroll up a little? Where's the reading?
Okay. 10.
Oh, 5.
10.5% is a fraction. So let's just copy this percent. And you tell me, how did you convert it to a fraction? Okay, there's the percent. Now, how did you convert that to a fraction?
What I did was what I did now, I put the 10.5. It's 10.5%. I get it back to fraction, to decimal.
Okay, so what's that equal to as a decimal?
That is equal to 0.105. When I do something, and then I get the 21 over 200. What did I do again? Oh yeah. I turned the 10 I put the 10.5 into the calculator. That's what I did.
Okay,
to
so you made the 10.5%
Yeah.
10.5. Okay.
Yeah.
Then what did you do?
If I touch percent sign, I get 0. It show me the fraction 0.105, and I don't feel satisfied. So I said, how much is what fraction is 1.5 105? And then I touch it again and it showed me 21 over 20. So I'm saying if I move, let me see, go back to this. If I move no, I'm trying to figure out, did I get the 20 over 21 over 20 over 200. 200, yeah.
Now, Mercedes, you're doing this problem now. You don't have a calculator. How would you do it?
I maybe have to put the 10.5 over 100.
That's right, because the ratio of a number to 100 is percent. So
Yeah.
this 10.5 would be 10.5 over 100. So let me just
Yeah.
put that over 100, right? And put the 100 here. Okay, now 10.5 over 100, but fractions, we don't have decimals in numerators, right? So
Okay.
that's why it can't be C. We never showed a fraction with a decimal in numerator or denominator, right? They're always whole numbers. Now, so it's not this one, 10.5 over 100, but what does this convert to? I'll say these.
I divide 10.5 into 100
No,
by 10.5 by 100.
no. Now, to get 200, you multiply both numerator and denominator by 2. So this would be times 2, right? And then the bottom number times 2. And 2 times 10.5 is 2 times 20 plus 2 times 0.5 is 1. And that would give you your 21, right?
Yeah, the top is
And
21.
then 2 times 100 is what?
200.
That's right, 200. There you go. That's your answer. That's the way you do it. No calculator.
Okay. Okay.
You were right. Make it a decimal. 10.5 becomes 10.5, right?
Yes.
Okay. Then to get an answer that does not have a decimal in the numerator or denominator, you can multiply both numerator and denominator by 2. 2 times 10.5 gives you 21. And 2 times 100 gives you 200. And that would be answer D. Hello, Maureen. Answer D. Okay. No calculator, right?
I see Chastity.
Yeah, I
Maureen.
see Chastity's. Maureen is coming on too. Maureen is connected. Hello, Maureen. Maureen.
I don't see her mute there, not at all. Only the video sign.
Maureen. No, she's not on mute. Maybe she doesn't hear. She had a problem hearing us once before.
Yeah, I don't think she's hearing you.
Maureen. Okay, so I'll say you started this right, making your 10.5% a decimal 10.5, because 1/2 is half of a dollar, 50 cents, or 0.5, right? Then you want to convert this decimal to a whole number. So you can multiply by 2, and what you do to the numerator, you must do to the denominator. Okay.
Yeah.
You can hear me, Miss Barbara?
Hello, Maureen. Now I hear you.
Okay.
Yeah, okay. So we oh, Maureen, you didn't send me your homework. What happened?
I didn't get chances at him because that is my last running round.
Oh, okay.
And I not too long to get back if I get him the COVID test and thing.
Oh,
Yeah,
that's right, because for your trip, you've got to have that
Yeah.
test, right?
yeah.
Okay, so Mercedes sent hers in. She did good on it too. We're doing number 5. She had number 5 correct, and I was just finding out how she did it. And she recognized that 10.5% can be converted to a decimal, 10.5. So since a percent is a ratio of a number to 100, that would be 10.5 over 100. But
I know.
we don't have decimals in our numerators and denominators. So to get this to a whole number, we can multiply by 2. 10.5 by 2, we get 21. But you must multiply the denominator by 2. 2 times 100 is 200. And that's answer D. Maureen, any questions on that?
So D.
Yes. Okay, Maureen, since you came in late, Mercedes is going to teach you the first four. Right, Mercedes? Since we went over it, Mercedes can tell you just how we did it. All right. All right.
Okay.
So the first question, you have a diagram there.
Mhm.
And what mixed number is represented by the shaded portion of the above diagram? Now, Maureen, what's a mixed number? What's a
And mixed number
mix?
is like mixed number is like 15 and 1 over this.
15 and 1?
Like a mixed number is if you got one number and then it's a number over the other number.
What is the number? You not tell me what the number is.
Okay, I got over 20 then.
It's what?
Suppose a mixed number is like you could got mixed number 3 and 3/4.
Okay, right. You gave me an example. So a mixed number is a whole number and a fraction,
Mhm.
right? Now, when you look at these four circles,
Uh,
how many whole numbers are there?
you got 3. 3, you got 3, 4, 4,
No, there are four whole numbers.
4, 4 is 8, 4 is 12, 4 is 6, and 4 is 20. Yeah.
No, there are four whole numbers. Each circle
Yeah.
represents a whole
Right.
number. So you have
Right.
1, 2, 3,
3.
4. But
Yeah.
they want to know what mixed number is represented by the shaded portion. So the shaded portion represents what, Maureen?
It represents. Oh, I see.
The shaded, what does it represent? What number?
The shaded one.
Yes.
Oh, you mean all 3 big ones?
What mixed number is represented by the shaded portion?
Oh, 1, 2, 3, 4, 5. It's 5. We 5 that ain't shaded with the one that's shaded.
Mercedes, explain to her what this represents.
Shaded number, the amount shaded was 3.
I know.
Three
Yeah,
whole
circles.
circles. And go ahead, Mercedes.
And in the fourth one, you have 3 shaded, and you can't say 1, 2, 3, 4. You can't say 3/5 because it's not 5. The whole is not divided in 5, so you have to say 3/8.
Right, because there are 4. This is sliced into 8 slices, right?
Yes.
So the whole is 8 here
8,
of the
yeah.
slices. So 3 are shaded. So what does this represent, Mercedes?
That's 3.
3 and what?
3 and 8.
3 and 3/8.
Yeah,
that-
I got that.
Okay, so 3 and 3/8 was answer C.
See. Yeah, I got that.
Okay. Okay. Now, Maureen, did you try number 2?
Number 2, I get out 7/10.
Very good.
Yeah.
Yeah.
That one Mercedes got when we went over it because she put the 14/20.
Yeah, but you
Okay.
say, yeah. Mm.
But we
you
wanted
said-
the, what did
But
we
you say
want?
burnt in the lowest term.
Yes, we
Right.
wanted it in the low. Well, you're right. So you are absolutely right. In lowest terms, so you can't leave it as 14/20. So let's go to number 3. Very good, Maureen. Let's go to number 3. Number 3, Maureen. Did you do
What?
that one?
No, I didn't do 3.
Okay. Don't worry. Mercedes is right here ready to explain it to you. Mercedes, tell her how to do number 3.
I try again. Okay, we look at the time, say 3 inches on a map represent 100 miles of real distance. The distance between Adams and Monterey on a map is 7.5 inches. How many miles separate the two cities in reality? So first I looked at, that says, okay, we have 3 inches represent 100 miles. and then you have 7.5 inches left. So we're going to see how much miles can we get out of 7? How much inches? Or we're going to divide up 7.5. So I convert that to 2. I get 2.5 for. Can you scroll up a little bit, Miss Barbara? I remember how I did. I get 2.5. So I changed it to decimal. I put 3.5 over 3.
7.5 over 3.
No, 2. I changed the half to 2.5 times
Right.
100.
Right.
And then I if you multiply that mean 2. If in 7, if you divide out the 7, you're gonna get 2.5.
That's right here. 7.5 over 3
Yeah.
and divided by, because 3
3.
represents 100 miles,
Yeah,
right?
yeah.
So
Yes.
2.5 would
They give
be
you,
the factor you multiply by 100. Maureen, you
yeah.
follow?
Yeah.
Okay, go ahead, Mercedes.
So that 2.5 times 100 plus the half. When you get the 2.5 is 200, because when you multiply 2 by 100, you get 200 plus
Right.
the half, which is 50. So it's equal half times 100 again. As half of 100, you get equal 200 plus 50 equal 250.
Okay.
Okay.
So
Okay.
that's the
Got it,
answer.
Maureen?
Yeah.
Very good, Mercedes. Okay. So,
Okay.
all right, let's go to number 4. Maureen, you think you can do number 4?
I work it up, but I get 1 9, but I don't know if it right.
You got 1. How did you get 1 9?
I work it up, but I got the piece of paper now. No, I spent the paper.
Okay. All right, Mercedes, explain to her how you do number 4.
And number 4.
Explain how you did number 4.
Okay. The reading say Betty scored 36 out of 45 for her maths test. What fraction did she get wrong? So first of all, for you to get the fraction, you gotta subtract 36 from 45, which leaves with 9, means she got 9 wrong. Okay. Then you're going to put the 9 upon 5.
No, over 45.
Over 45, pardon me. Okay, so you're gonna work out at you're gonna get a number that can multiply both numbers to get to your answer.
A number that divides into both numbers.
Divide both numbers, beg your pardon.
Okay.
So
All right.
we use because 9 5 is 45, we use 9. So 9 into 9 is 1, and 9 into 45 is 9. It's 5, sorry. So you have 1 upon 5. So
That's
A
your
is
answer.
Okay.
All right, Maureen, because
Yeah.
what Mercedes did, she found if she got 36 right, how many did she get wrong? Since the question asked you what fraction did she get wrong, so she found the number she got wrong was 9. So the number represents the part. The whole is all of the questions, 45. So 9 over 45. If you take factors of 9 and 45, the greatest common factor is 9. The greatest common factor is your common denominator. All right. And that's how she got the 1/5, which is answer A. Not 1 over 9, Maureen.
Okay.
1 over 5. Questions, Maureen? You okay with number 4?
I'm okay, yeah.
Okay. All right. So we were on number 5.
Okay.
Okay. Mercedes, explain number 5. Mercedes,
Okay.
you're on mute.
Yeah.
She done that already.
Yeah,
Number 5.
okay, go ahead.
Yeah.
Oh, you have
I
any
think,
questions, Maureen?
I think she heard when she came on when we were doing
Okay,
that.
so you're okay then. 10.5%.
Right.
Mercedes made it a decimal 10.5. So
Uh-huh.
the ratio of a number to 100, this would be 10.5 over 100. And then she converted it to a whole number by multiplying numerator and denominator by 2.
Uh-huh.
And you
Uh-huh.
get the answer D. Okay, now, Maureen, we're at number 6. Mercedes had that one correct. How would you solve this one, Maureen?
I said, let's say that is
What?
0.3% equals to. I put my answer as 3 over 100.
3 over 100?
Yeah.
Okay, let's just take this. Now, remember, this is 0.3%.
Yeah.
Okay, so let's sorry. Let's see. Okay, now, Maureen, 0.3% will be what as a decimal? What would that be equal to as a decimal?
30.3. No, 3%.
No, that's 0.3%. How do you go from percent to decimal? What do?
You move the thing one side.
Mm-mm.
You move the decimal point one side.
How many, you move it one?
One side.
Which side?
By the 0. In between the 0 and the 3.
She says, how do you move from decimal
Well,
to
the go from
per-
percent to decimal. What's the rule, Mouse Lady?
or what I did was I divide 0.3 by 100. I do 0.3 divide 100 and I get 0.003 for the decimal. Let's see.
Okay.
Yeah.
Divide by 100, or you shift decimal point 2 places to the left, right? So,
Yes.
so Mercedes divided by 100. That's how you go from percent to decimal. So she divided the 0.3, 0.3. Okay. And she divided this by 100. And what did you get, Mercedes, when you did that?
I got oops, sorry. I got 0.003. Did I miss?
You got 0.0003.
0.03.
And what is that equal to as a fraction?
And that is equal to 3 over 1,000.
That's right, 3 over 1,000. So, Maureen.
Yeah.
Okay, to go from percent to decimal, remember we said you do what? Divide by 100 or shift your decimal point 3 places to the left. Now your decimal point is here. And if you move it, okay, 0.3%. Okay. Now the decimal point is right here. If you move it 3 places, what do you get, Maureen? 0.1. 3 places to the left.
0.3.
Move that decimal point 3 places to the left.
1, 2, 3.
Move decimal point 3 places to the left.
1,
That's the
3,
same
4.
as dividing by 100. So
Okay.
what do you get when you do that? What should this be, Maureen?
0.3.
I'm sorry.
Should I-
I'm sorry. That's 3, 2 places. 2 places
Yes,
to the left.
is
That's the same as dividing by 100. So what would this be? After you move the decimal point, 2 places to the left. What would this number be as a decimal?
0.3
No, you didn't move it at all.
or 0.03.
That's 1 place. 2 places.
0.03.
0 point what?
0.03.
0.003. That's right. But 0.003 is the same thing Mercedes got here, right? And place value, this is tenths, hundredths, thousand. So this is 3 over 1,000.
Okay.
Okay. Move decimal point 2 places to the left.
can I ask a
Is
question?
yes, go ahead. Same
Miss, I put
as dividing
yeah.
by 100. And moving 2 places to the right is same as multiplying by 100. Okay.
Okay. So Miss, I put
Yes.
0.3 upon 100.
Right.
Then I use 10 and multiply 3, I get 30. I use 10 multiplied 100, I get 1,000. Then I strike the 0 from the 30 for 3 over 1,000. Is that a good way to do it too?
You multiplied 1.
I use 10 to multiply both denominator and numerator.
Yes, that's fine. That will still give you 3 over 1,000.
Yeah.
Because 0.3 times 10 is 3, and 10 times 100 is 1,000.
1,000, yes.
Yes, that's absolutely a good way to do it, because now you say, okay, now if I multiply this, I don't have my decimal. I just have the whole number 3, but I had to multiply the 100 by the same number, and 100 times 10 is 1,000. That's right.
Okay.
So your answer is D.
Thank you.
Very good. Maureen, any questions?
No.
Okay, so you had that one correct. That was number 6. But number 7,
I didn't do it, Miss. I
you
have to
didn't give
leave
me
it.
an answer.
No, Miss, I didn't do it. I leave it. It was
Don't worry, Maureen will help you out. Right, Maureen?
7.
Number 7. Now, you know this means greater than, less than, these symbols, greater than, greater than. This is greater, this is less. This is saying which statement is true. Is 0.37 greater than 59%? Is 59% less than 0.53? Is 75% greater than 0.80? Is 0.095 greater than 5.9%? Okay.
I wrote them all out, but I'm doubtful.
So what was your answer, Mercedes?
I think I choose C. If my memory serves me right, I didn't know a piece of paper, but I just discarded because I thought it was too doubtful. I do all of them to see which one would be leading.
Well, it's not C. What would you say, Maureen?
I had said A.
Now, you could make your decimal percent and your percent decimal so you can compare percents to percents, right? So let's do it like this. Maureen, 0.37 is what percent? What I'll do is take this and copy it. And let's make our 0.37 a percent. So 0.37 would be what percent?
would be 37%.
That's right. So we put, let's make this a percent. So this becomes 37. And let's put our percent sign here. Now, is 37% greater than 59%?
No.
No. So we know that's not true. Mercedes, following?
Yes, yes.
Okay, so we changing our percents to decimals or a decimal percent, whichever case we have to do. Now, this is decimal, we made it percent. Now let's
Oh.
just,
Now I got what to do. Holy
you
cow.
got it? Okay, now let's just take this one.
Because
put
I
it
understand
here.
it. I'm sorry, I understand the signs. I know what is the point we're
You,
graded
you
from.
know the greater than, less than, right?
Yeah.
So 0.53 Mercedes is what percent?
0.53 is what percent is?
Yes,
53%.
that's right, 53%. So let's just make this 53%. Put our percent sign there. Okay. Now, Mercedes, is 59% less than 53%?
Is
Yeah.
53% less? Yes, it is. Less than 59.
No, no. I'm
What
sorry.
on?
Is 59% less than 53%?
No, no.
No. So there again, a no. 59% is greater than 53%. So that statement is not true. No. Got it? Everybody following me?
Yeah.
Yes.
Okay. Now let's go to 75% and 0.80. Let's make our 0.80 a percent. Okay. Let's copy this here. All right. Okay. And 0.80, Maureen, is what percent?
80%.
80%. So let's just make this 80%. 80 here, put our percent here. Percent sign. Now, Maureen, is 75% greater than 80%?
Yeah.
It is?
Yeah.
Oh,
75% is greater than 80%?
No.
No, if you have 80% of something, you have more than if you have
more than
75%. So this is not true. No. Got it?
Mm-hmm.
Okay. Now let's take our last one. 0.095 greater than 5.9%. Well, we know if they all know this one has to be true, but let's just prove it. Okay. Let's put this here. Okay. Now let's make the 0.095 a percent, Mercedes. What would 0.095 be as a percent?
95%.
No.
Oh,
Multiply by 100 or shift 2 places to the right. So what do you get?
okay. I'm sorry.
2 places, your decimal point is right here
Oh,
between the
that's
9
okay.
and the 5, right?
I put 2 0 instead of 1. Sorry.
No, move it
No,
2 places to the right. So your decimal point is shifted from in front of this 0 to between the 9 and the 5. Same as multiplying by 100. So this becomes 9.5%. Right. So let's put our decimal here. Put our percent sign. All right. Now, 9.5%. Is that greater than 5.9%?
Yeah.
Ladies?
Yes.
Yes, this is true. So that's a true statement. Yes, it's greater, right? So your answer would be D.
Okay, miss, let's go back to no, see, I don't get it.
Okay. Okay. Now let's start with A.
No,
I have
miss.
a question.
Sorry. When the mouth of the V is open and the mouth is pointing to a number, when it's the open part of it, it does tell you that the number is greater or smaller.
Well, greater the point of the V is pointing to the right. Less than is pointing to the left. So less, left. See, so it's pointing this way, which is left, my left. And pointing that way is my right.
Yeah.
Okay, so this symbol means less than.
The point mean the point, okay. All right, let's go back to 75%. The point is to the 80.
So the point is to the 70.
No.
This is
Remember-
greater than.
Yeah.
All right, that's greater
Okay.
than. If I
So,
take
look at
this one, go ahead, Mercedes.
So the point is to 80%. See what I mean?
Okay, now
So when
wait, let's start in the
But-
beginning. This
Okay.
is saying 0.37 is greater than 59%. That's how you read it in words. You're saying 0.37 decimal is greater than 59%.
So when the mouth is open to the number, that means that number is greater.
No. Think about what I'm saying here. This
Okay.
symbol means greater than. That means whatever's at the left of it, you're saying is greater than what is to the right of it.
Okay. So
So
all right.
here, when you get to this one, that's
Yeah.
saying over the left, 59%, that value we're saying is less
that's
than
the one
at
on
the
the right.
right, 0.53. And over here is saying on the left, 75% is greater than what's on the right, 0.80. Got it? And 0.095 decimal, we're saying this is greater than the 5.9% on the right. You got it?
Yes, Miss, but I think the symbol set wrong. Go back to C again on
Okay,
the right.
right here, C.
Yeah. 75% is saying right here is greater than 0.80, which is on the right. Okay.
Yes.
But when you come back over this side, it is saying 75% is greater than 80, which is on the left, on the right.
Yeah, but it's the same thing, except that 0.80 is a percent. There's no different. The difference is we converted our decimal to a percent, but there's still a greater than. The symbol doesn't change.
Okay.
Symbol doesn't change. We just
Oh, when
changed the
it's-
format.
You're saying when it was 0.80, it is less than 75%.
No. 75%, it still reads the same, Mercedes. 75% greater than 0.80. Make the 0.80%, you're still saying 75% greater than 80%. If it's greater
Oh.
than the decimal, it's greater than the percent.
Okay.
Because the decimal is equal to this percent.
Oh,
Notice I'm not changing these greater than, less than symbols. I'm just
Okay.
changing the format of the numbers that we are comparing.
okay.
Like here, if the decimal 0.37, the statement is saying is greater than 59%. The fact that I changed the 0.37 to a percent is still saying is greater than 59%.
Okay. Got you.
You got it?
Yes.
So you're not
So
changing the
9.5
greater or less than, you're just changing the format that you're comparing.
Yeah, 9.5% is greater than 5.
It's greater than 5.9 because
So
9
9
is
big-
greater than
bigger
5, right?
Got it.
Okay.
Right, because when you switch it over and put in the percent, I thought you switch around the sign.
No, the symbol greater or less than doesn't change.
Okay.
We just putting them in a format where we can compare.
Okay.
percent, 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 percent. Now, you didn't have to do this if you know that a decimal to a percent is multiplied by 100. You say, well, 37 is not greater than 59, so this can't be true, right?
Yeah.
59 is not less than 53. Okay. 75 is not greater than 80. It's less than 80. Okay. But then when we get down here, 9.5 as a percent, or 9.5 as a decimal, 9.5 is greater than 5.9. So whether you had percents or you just had decimals, you would still get the same results.
Okay.
Got it?
Yes. Thank you.
Any questions? Number 7. Because Mercedes, you left that one. You didn't
Yeah, I didn't do it.
answer. Okay.
I do them all. Oh, and I said, I don't know what I'm not getting. So you know what? Let me
Okay.
read.
But I converted them all to the same format, but you didn't really have to do that, right? You could have made the 59% a decimal, and it would still be the same. 0.37 is not greater than 0.59, right?
Okay.
So no matter how you express it, you get the same results. Okay. If you drop the decimal completely and said whole number 37 greater than whole number 59, still be a no. It's still not true. 37 is less than 59. Got it?
Okay, yes.
Questions?
Okay.
Everybody following number 7. Everybody can do number 7 if you had this same kind of problem again, right?
Yeah,
Okay, Maureen, you okay?
yeah, to be honest.
Okay.
I was early this morning, guys. I don't know, early. Yeah.
All right. Now, which of the following is in increasing order? Now, Mercedes, you said A. Let's see what Maureen says. Okay, and I'll put this all on one screen. Now, which of the following is in increasing order? Which one would you say, Maureen?
Let's see, 'cause I didn't do that.
But look at them now and tell me which one. Now, this is another one where you got percent decimals. So, but you can make percent decimals or you can make decimals percent, either way. But which of these A, B, C, D is in increasing order? In other words, you're going from low to high. Which one would you say?
Okay, from
Maureen?
low to high.
Yes.
Okay.
Mercedes said A, and A is not correct. So
Ooh,
you're between B, C, and D. Which one, Maureen?
Okay, I will say D.
You say again what you said?
D.
You saying D?
Yeah,
D as in dog?
yeah.
Okay, D is not correct.
Oh boy.
Maureen, 0.67, 0.8. Now you're saying 70% is greater than 80%. That's not true,
Oh, I see.
right?
Yeah.
If you made these all decimal, 0.67, 0.8, 0.7, 0.70 is not greater than 0.80. So that's, which one is the biggest of these, Mercedes? Of all these, which one is the largest?
okay. Let's say B.
No. What I'm asking you is which one is the largest?
Out of all the numbers.
0.8, 0.67, 0.8, 0.8, 0.67, 0.70, or 70%. Which one is the largest?
The largest, I would say.
Out of 0.8, 70%, 0.67. Which one is the largest?
0.67. I would
70% of 0.8. Which one is the largest?
say 0.67, 0.67.
That's the smallest. I say, which is the largest?
Smallest? Holy cow. Then it is 0.8.
That's the largest, right?
Yeah.
So, which means that in increasing order, the 0.8 should be the last one.
Okay, we're increasing.
That's
From less,
increasing, and the largest is 0.8.
so you're going to start from the less one.
What is the smallest, Mercedes?
So the smallest one is 0.67.
That's it.
So the answer is B.
That's it. B.
Oh boy.
I see.
You see, now if you put the largest and you put the smallest, then you say, well, only one fits here, where 6.7 is the first one and 0.8 is the largest, which is the last one. So answer B. Right?
Mhm.
So that's how you figure that one out. You look at, because remember, look at all the numbers. They're all given with the 0.67 as a decimal,
Yeah.
70 as a percent, 0.8 is a decimal. So it doesn't really matter whether they decimal percent, because 70% again is 0.70, right? So you're really comparing 0.8, 0.67, 0.70. Identify your largest, identify your smallest, and then your answer. There's only one answer that has 0.67 first and 0.8 last, and that's B, right?
Mhm.
The 0.8 is the smallest.
0.8
Largest,
is the
largest,
largest,
sorry.
and
It's on the start.
0.67 is the smallest. You got it?
Yeah.
Okay. So when you're putting something in increasing order, or decreasing order, identify your largest value, identify your smallest value, and then put the others between those, and then pick an answer.
Oh, because 0.8 is 80%.
That's right. Absolutely. And 0.67 is 67%. So you really like saying 67%, 70%, 80%. 67% the smallest, 70% the next, and then 80%. Got it?
Mhm.
Mercedes, you okay with that now?
Yes, thank you.
Yeah, this is like similar to the other problem where we had percents and decimals, right? But you could really just say whole numbers. 80, 67, 70. Be the same order, correct?
Okay.
You could just drop your decimals and just say 67, 70, and 80.
Really?
Sure, you don't have to use the decimals, because 0.67 converts to what? 67. So you could have just said, if
Oh,
decimals give you a problem, just say
I should have known
67,
because
70, and 80. It's whole
yeah,
numbers, right?
because 70 is like 7 upon 10.
Yeah, 70% is a whole number 70. It's a decimal 0.70. 0.80 is a whole number is 80. 67.67 is a whole number 67 without the decimal. So you can just drop the decimals and use just the whole numbers. 67 is still the smallest, 70 is in between, and 80 is the largest. You got it?
Yes, miss.
So if it's easier for you to work without the decimals, you don't have to. Just make them whole numbers. Got it?
Okay, miss.
Okay, let's go to number 9. Mercedes, you said the answer was 4. Maureen, read number 9 and tell me the answer.
Okay. An oil container contains 7 1/2 liters of oil, which are poured into 2 1/2 liter bottles. How many bottles are needed to fill the 7 1/2 liters of oil?
So your container has 7.5 liters.
Oh.
So
I
we
got,
have,
I got my answer as 3, but I don't know if it's right.
that 3 is correct. Now, tell me how you got it, Maureen.
I divide numbers, but I can't remember which one I divide first.
Yeah, you divide. Divide is correct.
Yeah.
Okay. What did you divide?
I can't remember. I think I remember I divided
Okay.
2.5 by 7.5. I can't remember.
No, the
No,
other
that's what
way.
it
7.5
is.
divides 7
By
and
1/2,
1/2.
by 2.5.
Yes, by 2.5. Divide 7.5. Let's put that here. Put here so you see that that's a mixed fraction by 2.5. And what does that give you, Maureen?
3.
3. That's your answer.
I
Well,
never
say
think
that you
of
had
it
4. How did you get 4?
because I got the 3 and then I say half leave. And I'm saying,
Said
Miss
what?
Miss Barbara would say you can't have 1/2 in a bottle. So I squared to 4.
You said what?
I'm saying if in 7 I got 3. I divide it with 7 and I get 3 2s. Okay, that's 3 bottles. And I still have half leave. You can't use the half for an old bottle. So I just square it to 4 for the half. So I don't know what I did wrong.
So
right
what did you do with the 7?
I divided 7 into, I get 3 2s out of the 7. That's which is 6, 2, 4, 6. And I said 1 leave. 1 leave with the half, which is 1.5. So you have to put the 1.5 in 1 bottle. So I said 3 and 1.5. So I just squared to 4.
No, but you got 7.5 the container has. For a container that holds 7.5, you want to pour 2.5 liters in there, and you want to know how many bottles you need to fill the 7.5. So it's got to be the 7.5 divided by the 2.5. You can't use the 2. You got to use the whole thing.
Okay, let's see.
Yeah, it's 7.5 divided by 2.5, and that gives you 3.
So 2 into 2 times 7 is.
Yeah, 7.5 divided by, so this becomes, okay, so you want it, you can make it a decimal if you like, 7.5
0.5 into 15 3.
divided by 2.5. That's right. This is the way it will look. Okay. And put 2.5. Let's see. Okay, this will be 2.5.
I didn't remember I could put a fraction out.
Yeah, you could make it a decimal. You could make it a decimal, and 7.5 divided by 2.5 gives you what, Mercedes?
You say that again?
7.5 divided by 2.5 gives you what?
7.5 divided by 7.5. Oh, 7.5 divided by 2.5.
Yes. Mental math.
Give me 3.
3. That's right.
But,
Because 3
but,
3 times 2.5 gives you 7.5.
so miss, pull down the screen a little bit.
Mean back up here?
Yeah, yes. If I think of putting out like that, I could look at it and get the answer 3 too. Because I would say 2 times 7 is 14 and 1 make 15. 2 2 is 4. and 1 make 5. 5 into 15 is 3.
Yeah.
But I did
right.
another way. I did another way
Yeah.
on my end.
Yeah, because you're saying I've got a container that holds 7.5, right? 7.5 bottles. And I've got a 2.5, well, liters. And I have 2.5 liter bottles. How many of these bottles will I have to use to fill it? Well, 4, you said 4, but 4 times 2 is 8, and 4 times a half is 2. That's 10. That's a container containing 10.
Okay.
So your container is not a 7.5. Yours is like contains 10 liters of oil.
And all I need to do was to just put the fraction down and do it, and I'll get it.
Yeah, just take what the container holds,
2.5 and
divided by the number of bottles, the size of the bottles that you want to fill it. And that's 2.5 liters. So 7.5 divided by 2.5 gives you the 3 that Maureen got. And that's the answer, 3 bottles. Got it?
yes, thank you.
Okay. Now let's look at number 10. Maureen. Now, Mercedes got this one correct. Very good. Now, Maureen, how would you solve this? 5 over 100 plus 3 over 10. What would that be equal to?
I get 0.35.
0.35. How did you get that?
I work it out with my calculator.
Without the calculator, how do you do it?
I didn't do it without the calculator.
This is not a calculator problem. This is a mental math problem. Right? Mercedes, did you do it mental math? 5 over 100
I
plus 3
Over 10.
over 10. Now, this is not a calculator problem. This is mental math problem. Now, you know to add fractions, your denominators have to be the same, right?
yes, that's the
Mhm.
first.
Okay, so how would you make these denominators the same, Maureen? What would you do?
Oh, you mean it multiply by 10?
Right, so what does this
Yeah.
become? 5 over 100 would be equal to what?
5 over 100.
5 over 100. Make the 3 over 10 something over 100. What would that be?
5 over 100. 5 over 10.
No, 3 over 10 would be what number over 100?
100.
In other words, I'm asking you to take this 3 over 10,
Uh-huh.
make it n over 100. What is n? What's the
30.
value? 30. That's right. So this will be 30 over 100. So 30 plus 5 is what?
35.
35. 35 over 100. And 35 over 100 is answer B.
Hmm.
Excuse me a minute. Let's see who's. Excuse me 1 minute. Okay. All right, so that would be the answer. The 35 over 100 convert to decimal. That would be answer B. You see why
So
that's not calculated? That's mental math.
Yeah.
yeah.
Okay, answer B. Okay. Any questions on percent, decimals, fractions?
No, miss, just keep practicing and you get it good.
Okay. All right. So let's look at, I want to look at, let's see. I want to do a new share and let's look at look at the topics we want to go over today. Just a minute. Let's see. New session discussion. Okay. Okay, so new share. Let's see. Hold on a minute. These. Okay, new session.
I gotta look behind my bed and see if I find my money.
What's the matter?
I say I had $160 in the envelope on my bed. I don't know if it dropped behind the bed. I don't know if I gone.
Okay, let's see.
I got this morning to go to buy things and I can't find the money. So I gotta pull back the bed and see if it dropped behind there.
Okay. Okay, new session. Let's see, can you see this? Can you see Math GED Prep? Applied
Yeah.
Math? Okay.
Yeah.
All right. So we're going to start now on some setup problems, because some of the problems you'll do on GED are not ones where you have to solve for an answer. You just have to do a setup. Okay. So let's take some examples. Now you see this one. Maureen, I want you to read this and tell me the answer.
Okay. Mark had $572.18 in his checking account. After writing the check, he had $434.68. Which of the following equations would be used to find the amount of the check?
And we call the check the variable C. So which one of these, A, B, C, or D?
Yeah. Which of the following equations would be used to find the amount of the check?
Now, just tell me in words how you would find the value of the check. Use the numbers here, Maureen. Just say in words how,
okay,
if you know how much you, okay.
Yeah, and he spent, let me see, after the writing the check, he had, okay, you got to sidetrack.
That's right. You subtract the amount of the check from what?
From what he, okay. But the one that he had?
Yeah, say the balance he started with. We could call that like an opening balance, right?
Okay.
So you have to subtract that amount of the check from the opening balance to get what he would then have. So which answer would you say matches what you just said in words?
Okay. B?
That's it. Very good. Mercedes, you get that?
Yes, miss.
Okay. So answer
B.
B. So when you have a question like this, say it to yourself in words how you would do it, and then translate your words into the math. So like Maureen, you said, subtract. You immediately say subtract the amount of the check from your opening balance, which is here was 572.18, and you get what he had left was the 434.68. So that would be answer B. Any questions on number one?
No.
You said number B was the answer?
Yes. You understand how
I'm thinking
Maureen got B?
She to subtract?
Yes, the amount of the check subtracted from we'll call this opening balance. The $572.18 is the opening balance. So she subtracted the check, the amount of the check from the opening balance, and it said after writing the check, she had $434.68. So after getting the difference between the check that Mark wrote from his opening balance, you get now his new balance, the $434.68. So that's the only one where you're subtracting out the amount of the check to give you what you now have is B. Right?
Oh,
You don't
so
see
yeah,
that any place else. Do you
so
see that any place else? I'll say these.
no, what I'm just
It
trying to prove.
says to add it. You wouldn't add the check, right? Because you've taken it out of the account. You wouldn't multiply it. And you would subtract two checks. This is D is subtracting two checks. E is taking what you had left and added it to the check. That
Yeah, I did.
won't give you the balance.
Yeah, I did. I got it.
You got it? That
The
and
amount,
she's
that, the
coming up
amount,
with the opening balance right here.
the amount that was taken was 137.5. So I had it back with had it to the 434.68, and I get back there.
That's it. That's how you could check it. So whatever you have for your check, you add that to this new balance, and you should get back your opening balance. Very good. Okay. Now that's a setup problem. You didn't have to solve it, you just had to pick the setup. Now, let's look at another one. Now, let's see if I have it here. Did you get the list of formulas I sent you? Did anybody get the formula? I sent you a formula sheet. Let's see.
Through the mail?
Yeah, I emailed it to you. Well, I don't see it here. I sent it to you email, right?
Let me check.
But probably you know, Maureen, you know the formula for finding interest or finding principal? Of finding interest, if you have principal, the rate, the time, what's the formula? What's the interest formula? Mercedes, you know it?
I don't think I
So you
remember.
got to multiply the interest by the amount of money I had, right?
Interest equal, let me just write it out. Interest equal principal time rate times the time. You remember this?
Yeah.
I equal PRT. You remember that formula?
Yeah.
Mercedes, you remember that formula?
Yeah.
Principal time rate time.
Principal time rate time the time. Now, the rate is usually percent, but we convert it to a decimal. So I'm putting here decimal. You have to convert that to a decimal. All right. CIMAL. So the rate is decimal. The time is in years. Okay, so let me put, that's the units of the time. The time is in years. Okay. So now you know your formula. So if you're getting interest on something, you start out with an amount, you make some interest, and then you add that interest to what you started with. Okay. So Mercedes, read this problem and tell me which one is correct.
Jones borrowed $1,300 to buy tools for her job as an auto mechanic. The loan is for 1 year and 6 months at 9% simple interest. Which of the following expression could be used to find the amount she will pay back at the end of the loan period?
Okay, now the $1,300, that's the principal, right? That's the principal. The interest, the period of the loan, the time is 1 year and 6 months.
Mhm.
So I'm underlining the things you'll need here. So now you know the principal, that's what she's borrowing. You know her loan period, 1 year and 6 months, and you know her interest rate. Now, Mercedes, which one of these would give you the amount she will pay back at the end of the period? Which one?
She has 1,300 first of all,
Mm-hmm.
and then she have 1 year and 6 months at 9% simple interest to find the amount. The 9% simple interest, which of the following expression could be? So let's see now.
I remember we said the amount she will pay back. Okay.
Which mean she have to tell her what's 9% is the amount for
So what,
1.5 years.
now, what is she paying back?
1.5.
No, what's the total she pays back on this loan?
It will be the 9%.
No, what's the total payback?
1,200?
No,
No, hold on.
Maureen, do you know? What does she pay back, the total?
The 1.6?
No.
Oh,
Okay, the payback,
That is 1.5.
no, the payback is
it's
principal.
$1,300.
No. The
Oh, yeah.
payback is principal plus interest. When you borrow, you pay back what you borrow plus the interest,
Oh.
right?
Mhm.
That's how banks make money.
I know. So
I
the
think back
interest
to
is 9%, miss, right?
Well, 9% is the rate. So which setup represents what she will pay back?
Is that D, miss?
No.
No, I'm sorry. No. Can't be none of D nor E.
Oh, let's see.
No, I said payback is
Oh,
principal
payback.
plus the interest. Which one of those setups have principal plus the interest?
That's A, miss.
D. No, E.
E. Thank
E.
you, Maureen.
E.
E is the answer.
Yeah.
Remember, Mercedes, I said principal plus the interest. So you've got to have the 1,300 added to the interest. So it can't be A, B, or C, because you don't see principal added to interest. It can only be between D and E. And it's not D because remember I said the percent has to be a decimal. 9% is
Oh,
0.09.
okay.
All right. So the answer would be E. Mercedes, did you see why it's E?
So she have to have 1,300 times 0.
No,
Point.
1,300, that's the principal, plus the interest. See, this expression here is the PRT, principal times the rate times the time. And a year and 6 months is 1.5 years, right?
Yes.
1 year and 6 months, that's 1.5 or 1.5. The percent, 9% as a decimal is 0.09. 9 divided by 100. Questions?
So 9 divided by 100 would be how much more money, miss?
What was that, Mercedes?
I just want to know what is the amount of payback money.
No, you could figure it out. You could multiply this out and add it to 1,300. But for these setup problems, you don't have to figure these out. You just have to say what setup will give you the answer.
Okay.
See, which of the following expressions could be used to find the amount she will pay back at the end of the loan period? If you want to calculate it, you multiply this expression out, add it to the 1,300, and you see her payback is 1,300 plus the interest. That's found by P times R times T. Got it?
Okay. Thank
Question?
you.
Questions?
Mm-mm.
Okay. I sent you that. I'll send it again. I sent you the new GED formula sheet, and I equal PRT. The interest formula is part of that formula sheet, but you should know it. Actually, you should
But I
know.
think I'm thinking my phone, but I can't go into my phone now because I'm using my phone.
Okay. Yeah, I emailed it. When I emailed the work, I sent it, but I'll send it again. I'll make a note to send it again. Send formula sheet. Okay, let's look at, I think we have another setup here. Okay. All right, there's another setup.
Mm-mm.
Okay, let me scroll this down. Okay, Maureen, it's your time to read. Let's bring this down. Okay, I want you to read that one and then take a look at it and tell me what the setup. Okay, Maureen, read number 3.
If the square of a number is added to the number increased by 4, the result of 60 if n represent the number, which equation can be used to find n?
Okay. Now, this is very important. Square of a number. That
Mm-hmm.
means a number raised to the second power, right?
Mm-hmm.
Added to the number, and the number is increased by 4. Result is, that means equal, result equals 60. Now, n is the variable for the number, right? So you're using n. All right, Maureen, take a look at your choices. Tell me which one is correct.
Okay. They got n to the power 2 plus 460. That. Okay. I figured 2 answers.
There's not 2 answers.
I know.
There's only one answer.
If the square of a number is added, okay.
Increase by means what, Maureen? What operation? What mathematical
Add.
operation? Add, that's right.
Yeah.
So increase by means added. And of course, you know square raised to the second power, and result is means equal to 60. So if it's equal to 60, you can eliminate D and E, right?
Mm-hmm.
Right, Mercedes? You're on mute. Mercedes,
Sorry,
you're
I'm
on
sorry.
mute.
Yes.
And I
yes.
said result is 60. That means equal to 60. So if you know that's true, you can eliminate D and E. So you look at it A, B, and C. You look at ways you can eliminate certain answers and make your choices easier. So you can eliminate D and E because you don't have a 60 after the equal sign.
I know.
Okay, Maureen, which one is
So,
it?
Ice cream's right here.
okay. I will
Where?
say C.
You have money?
Chastity,
You have cash?
what did you say, Maureen?
I say C.
C. Which one do you say, Mercedes?
I'm sorry, Miss Barbara. I'm driving.
Okay. Which one would you say, Mercedes?
She from mute
I
again.
want to I'm trying to figure it in my head first.
Maureen says C. I'm said, what is your answer?
All right, let me hold on to A.
You would say A?
Yes. No, I'm sorry. C.
C. C is correct because it says added to the number
That's why I
increased by
said-
4. So you have to have the n plus 4 and
Yeah.
then you have to have the square of the number. And
So
that's only shown by C. Square of the number and then n increased by 4 is n plus 4. So your answer would be C. Got it. Very good. See how
Miss
you feel.
Miss,
Question?
so Miss, when you do all of that, you're supposed to get the answer 60, right, Miss?
Yes.
So how would you figure out that?
What?
You'd have to have a number that add to.
No, this you don't try to figure this out. You just set up because this is really a quadratic.
Oh,
The equation here is a quadratic. When you have a variable square, that's a quadratic. And
okay.
quadratic equations have two solutions. Okay, they have a plus and a minus. All right. So in this one, you're not trying to figure it out. You're just trying to pick the right setup to solve it. Got it?
Yes.
Yeah. Because the solve it, that's a whole different category that's coming up later. We're going to get into quadratics, but that's a later topic. Got it?
Yes, thank you.
I just want you to be able to look at the words in an equation and translate them to the math. Remembering certain things like is meaning equal, increase by meaning add, decrease by means subtract,
Like that.
square of a number raised to the second power, right? Okay. Decrease or less than means subtract.
Oh,
All right. All right. Okay. All right. We get it. We have another problem here. Okay. Now we're looking at a diagram. Okay. I am going to put this all on one screen. Okay. Okay, now can you see that diagram? Or a
Yes.
3-foot wide walkway is built around a swimming pool that is 20 feet by 30 feet, as shown in this figure. Now, there's your figure right there, right?
Yes.
This is your walkway around here, right? This is your swimming pool, 20 feet by 30. Okay. This is your walkway. Now, here's what you're looking for. In order to determine how much flagstone to buy, that is for the walkway, the owner needs to know the total area in square feet of the walkway. And we'll pick out the following expression that represents this area. Now, let's go back up here to our diagram. Here's your walkway, 3 feet. All right. Here's the pool. Here's the whole area. All right. Now we want to put flagstone on this walkway. And the owner would like to know how much flagstone to use, which means he would like to know the area of this walkway. So now just picture this, just look at this, and just tell me in words how you think you would find the area of this walkway. Just in words.
Multiply 20 by 30.
So 20 by 30 is the pool.
Uh-oh.
Remember I said, this is the pool right here, 20 by 30, because it says right here, the walkway is built around a swimming pool that is 20 by 30. This is the walkway right here. You see the walkway?
Yeah.
All right. This is the walkway. All right. This is the whole area here. And that's the swimming pool. In words, what do you think about this? What do you think you would use here?
You would
know.
understand.
Just kind of visualize having a pool sitting on a plot. And on the plot, you put in a walkway around the pool.
You said right across is 3 feet.
Yes. That means 3
So-
feet here,
The 2.
3 feet on this side, right?
Which you get the other side.
And 3 feet here and 3 feet here.
So either we add up all
Multiply
3.
Multiply what, Maureen?
3 by 3 by 3 by 3.
3 by 4.
No.
We get
Okay.
the ear of it.
Now, let me just give you a hint here. You need to know this whole area and this area. And the difference would be the walkway. So when I said this whole area right here, and the pool, and the difference would be the walkway. You have that picture in your mind?
Yeah.
Okay. Now, knowing that,
1.5.
okay, which one of these answers do you think would be correct?
Wow.
Let's go back up here. Picture it again.
20,
You've got
30.
30, you've got
Mhm.
3 feet here,
Mhm.
3 feet here, 3 feet here, 3 feet here. So what would be the area of this piece around the plot that's around the pool? What would be that area? The whole area that the plot that the pool is on. Just think of somebody's yard that has a pool. What would be the area of the yard?
3, 6, 9, 12.
No. What would be the length? What would be this length? Say this is the yard here, or the plot where the pool is. What would be that length?
Would be like
Here to here. What would you say that is, Mercedes?
mostly like 1.5 the 30 feet of the
No,
pool. Of the pool.
no, we're talking this whole piece there, including the pool. So
Oh.
what would that be? What would that length be?
That would be 3 times 30.
No. That whole length would be 30 plus 3 plus 3, which is equal to what? What's 30 plus 3
36.
plus 3?
36.
36. That's right. And
Mhm.
that's the length. The width would be 20 plus 3 plus 3. What would that be?
26.
Okay, so now you've got the dimensions of the plot where the pool sits, right? And you know the pool is 20 and 30. So Let's go down to the answers here. Which answer, Maureen?
Okay.
D.
Say it again.
D.
D, that is correct. Very good.
Same thing I have, miss. Same thing I think, miss.
That's
But
it. You had the same thing? Okay.
yes, miss. But please can you go back to the
Okay. So answer
pool?
D, because, okay, let's go back. Because remember I said to find the area of the place where the pool is built and
Mhm.
subtract the area of the pool from it, and then you get the walkway. So here we are here,
So how would it
33 and 3, that's 36, right?
wait,
20.
miss?
Go ahead, Mercedes.
Hold on, miss. You said 30. Okay. Why do you add the 2, 3 to the 30? And it's
Because
not
I
the
said
same.
the plot where the pool is. So you got to include this 3, 3,
Yeah.
and 3, 3. The pool
So all
itself is 20 by 30. The area where the pool is built is 30 plus 3 plus 3 times 20 plus 3 plus 3.
so let me get straight. We're talking the two alongside because you said 2 short sides 3 plus 3 plus the 30. That's 36.
Remember, I'm talking from here to here and from
Yeah.
here to here. Pool
Yeah.
sitting in the middle.
I understood.
Okay, so if this is 30, then the sides of 3 and 3, that makes this whole length 36. Got it?
Outside pool.
Question?
I'm just puzzled about because you have 3 and 1 and 3 and there. Why do you add the long side to the short side?
What do
You
you mean
got to
the
do
long
some,
side and short side?
because the long side is 30.
No, the 30 is the pool. This is a pool here.
Yeah.
Pool is 20 by 30. It's sitting on a plot, say in a yard, that's 30 plus 3 plus 3. That's 36 by 26. 20 plus 3 plus 3. So think of a 20 by 30-foot pool sitting on a plot that's 26 by 36.
Okay.
And the difference would be the walkway. The pool takes up the 20 by 30. The walkway around the pool would be the difference between the whole area of the plot where the pool sits minus the area of the pool. Because remember, the flagstone is being put right around the pool.
Okay.
That's the walkway. Can you picture that in your
Yes. Yes.
can you picture that, Maureen?
Yes, Miss Barbara.
Okay. Yeah. Because like if you have a pool, you don't put a pool as taking up all your space, right? The pool
Yeah.
is
Yeah.
maybe
Place
in
to
the
walk.
center of the space, and the space, the total space where the pool sit is always bigger than the pool, right?
Yes.
So that's where we have the 30 plus 3 plus 3 and the 20 plus 3 plus 3. And the difference is the walkway. If the pool takes up this, the whole area is this, here to here, here to here, then the walkway is this, the difference. So the answer would be D. Questions?
No, thank you, miss.
Okay, so we'll stop here. I'll send you all of this. We'll stop here.
Mhm.
I'm debating whether I'll give you the homework. Well, I'll do both. I'll give you a few more percent decimal fractions, and I'll give you a couple of setups, okay,
Mhm. Uh-huh.
on your
Yeah.
homework. That would be your homework. Um, Our class will be going until the end of July. Okay, we will not
Okay.
stop in May as we were told at the beginning. We will continue through the end of July. Now, I will send you a new outline of the topics
Yes.
we'll cover that will take us up to the last week of July. Okay, I'll get that out to you this week. Okay,
Mhm.
any questions?
No.
So next time we will go over our homework and then we'll start on mean, medium, mode, range, and the weighted mean. We'll do
Mhm.
several examples. I'll have you do some, and then we will discuss that. All right?
Yeah.
Yes.
Yes, question?
No, thank you.
Okay, so no questions. I'll say so long to everybody.
Till 4 o'clock, 4:30.
Yes, 4:30 for the college prep.
Okay, thank you.
Okay.
All right. Bye bye.